Hey there, I've been conducting a research on interconnection network topology. Essentially, I'm going to test different aspects, such as latency, etc., of various interconnection networks. For example, a mesh network. My first task for this research was to utilize the Verilog codes on router written by graduate research students from Stanford University, making sure that I have knowledge of how to use them. Details of their research can be found on this link. The codes for the routers were written before, but I still have to write modules to generate packets and send them appropriately into the routers and store outputs for analysis, like these ones. The routers as well as the modules that I wrote are mapped onto a Vertex 5 FPGA. RS-232 serial communication protocol is used to send data on the fly into the block RAMs of the FPGA that are then used to generate packages to send into the network. Bytes are transmitted into the FPGA through serial communication on MATLAB, which are then translated by a flit generator into packets. The packets are then stored inside memories waiting for injection into the routers. The output from the routers are also connected to block RAMs to store the output packages for later readouts. A MATLAB script was written by my partner to parse a text file and feed the FPGA with data. In the text file, each line is in the form injection router address, dash, destination router address, dash, the actual data being sent. Here's an example of a 4x4 mesh network. Here I've made a text file that sends one letter to all the other routers except itself. Router with address 0000 will send an A to all the other routers. Router with address 0001 will send a B to all the other routers, vice versa. If the router network is functioning appropriately, each output block RAM should receive a letter from all the other routers except itself. So now let me turn on the serial port and send in the data. From the lights, we see that the data are being sent in appropriately. Let me click this button. It takes the data input and translates them into flits and sends them into input memories. This button takes the input memories and feeds them into the router network. Now the packets should have traversed through the router network and arrived at the output block RAMs. The switches on the side are to select which output block RAM I want to read from. Now I'm selecting to read from router address 0000, and when I click this button, the FPGA is going to send the data that's been previously sent to router 0000 out to the computer through serial communication, and then it's router 0001 and 0010. Looks like the router network is working. Notice that the letters are ordered based on the order it exits the ejection port of each router. They're not in the order A, B, C, all the way to P because the distances between routers are different. The closer two routers are, the faster packets are transported between them. My next step would be to feed the routers with various bandwidth of packets and analyze the latency on the network.